Alright, it has been quite a while since we've done these video notes, so just to get everyone on track, we're starting with example number 1. You may not have a calculator, in which case I will help you out with some of these numbers, but we're going to be doing graphing with domain and range and transformations and kind of tying some different things together, ideas that you already have knowledge about. So it says determine the domain and range of the function, fill in the missing range in the table. So I'm given a domain, I want to find the range using this function. If you can tell the values on the graph, that's fine. Sometimes with parabolas, especially like in areas like this, it's hard to see where exactly specific exact values are, in which case I would suggest using your calculator and putting your function into y equals and then finding the y values in the table, which is what I did in order to get these values. You could also plug in your numbers for x and solve. It sounds like a lot of work though. The vertex on the graph would be at 0, -5. It is not represented, it is represented in my table, but there's not a good pattern here because my x values are not increasing the same. And then this would be the minimum of the parabola. The axis of symmetry goes through the vertex, so it would be x equals the x value of the vertex, which is 0. The domain of this parabola, and in all the parabolas we're doing today, is all real numbers. Remember, I can use any x value and I'm able to find a value for y. The range, however, in this case stops at my vertex, and all my y values are greater than or equal to my vertex. So if you hadn't noticed this before, the x value of the vertex goes with the axis of symmetry. The y value of the vertex goes with the range. And if I know that my vertex is a minimum, my y values have to be bigger than that, which is how we get the y is greater than or equal to -5. So the purpose of today's transformations, moving on to the next box, I'm taking my original transformation and adding 7 to it. So I'm taking this function, my f of x, and adding 7. Now if I were to put that in the calculator, I could do it like that. I could even just change it to say 3x squared plus 2, because if I combine this, it's plus 2. Either way. So all I really need to do is add 7 to all the values I got before, or put it in my calculator and just kind of redo it. So these would be your new values. If I want to graph some of these, I can do -1, 5, 0, 2. Then I don't have a value for 1 in my table. However, if I know that this is my vertex, then I know that my pattern, if this is at 5, then 1 also has to be at 5. So that's kind of one way to get some more points. I can't go any further because I don't have space on my graph. The axis of symmetry is still x equals 0 because I only translated it vertically. The domain is all real numbers. The range is going to stop here at my vertex, so all my y values are greater than or equal to 2. And all I did was add 7. So I translated 7 units up. That's all I did. Translated up 7 units. On the next one, I have my original function minus 2. So from this information, I know that my parabola is moving 2 units down. I know my domain will stay the same. I know my axis of symmetry will still be x equals 0. And if I'm taking this and I'm going down 2, I know that my vertex will be at 0, -7. So I just got a lot of information, which will be a minimum. And the range is now going to stop here at my vertex. So y will be greater than or equal to -7. So now all I have to do is fill in these other numbers, which I can either just subtract 2 from that first table, or put my new function in the calculator and look at the y equals table. Moving right along, on the back, we have a new example. So now we have a new parabola. -x² plus 9. Put those things in the calculator. 0, 9, 5, -7. Some of these values you can easily tell on the graph. My vertex is at 0, 9, which now it's a maximum. Remember, I have this negative, so it's pointing down. The axis of symmetry is still the y-axis, so x equals 0. Domain is all. The range, all my y values are less than or equal to 9. The transformation we're doing is -5. So my old vertex was at 9, so I'm going to translate it down 5 units, and my new vertex will be at 0, 4. I went 5 units down. Down. Domain is all. Vertex is at 0, 4. It's a maximum. The axis of symmetry is x equals 0. My range, since this is my new vertex, is y is less than or equal to 4. So all I have left to do now is fill in these other values by subtracting 5. And I can plot some of them. So I have 0, 4, and then 2 is at 0, which means that -2 is also at 0, because I have symmetrical points. -3 is at -5, which means +3 is also at -5, because again, symmetrical points. And here we are at our last example. All right, so this very last example we have, this looks super scary. It's not. Just as a quick review on some of these things, if I'm going to compare this to the parent function, the half tells me that it's going to be wider. The +4 would mean that from the original vertex of the origin, my vertex is going to move 4 spaces to the left, and then the -6 at the end would tell me my vertex moves 6 units down, which tells me my new vertex is at -4, -6, which is a minimum. The axis of symmetry is now going to run through the vertex, x equals -4. Domain all real. The range is now stopping at -6, so y is greater than or equal to -6. And then either using the graph or using the calculator, we can find that these values are -4, -6, 2, and 12. So if I take this function and add 3 to it, all I'm doing is shifting my entire parabola 3 units up. So these values can be filled in. The vertex that was at -4, -6 is going to move 3 units up and will be at -4, -3, which is displayed in my table. It's still a minimum, The axis of symmetry is x equals -4. The range is now y is greater than or equal to -3. Domain is all real. And I can plot some of these other points. So if the 0 is at 5, and if 0 is at 5, that means 8 is at 5, so that I have symmetrical points. And if -6 is at -1, that means -2 is also at -1. I think that's pretty much all I can plot. And then I can draw my parabola. You can draw yours better than mine. And that's it. So I hope that you were able to follow along there with me and understand what these transformations are doing and how it affects the table, the vertex, the axis of symmetry, the range, the domain. Be sure to fill out your feedback questionnaire, and I'll see you in class.